Welcome everyone. In this lecture we are going to discuss pre-activation values in neural networks, and particularly we will talk about the difference between the old and new notation. So let's start our discussion with a simple pre-activation value for a simple perceptron. So here you can see the pre-activation value is calculated, and the pre-activation value is then compared with some certain threshold called theta, and then if that pre-activation value is greater than or equal to theta, then we have like output +1, and if it is like smaller than theta, then we have -1 as the output. But let's talk about, if I'm talking about comparing with theta, so I can write this like z is equal to summation of I is equal to 1 and goes till n xi wi, and then I am just like comparing with theta, right? So I am just like getting this value and then I'm putting it just like here. Okay, and then what about it? So how it becomes like minus theta then? So when I move theta from this side to this side, so it is like becomes minus here. So then we are comparing with the threshold becomes 0. So this is what we have discussed in our previous lecture, that if we move theta, we are subtracting that threshold, then we are going to compare with the 0 because we have nothing left on this side. So this is how it becomes minus. So this is actually an older notation or pre-activation value that was used previously. Now we have a new notation here that is represented by plus b. So this equation is equal to sigma I is equal to 1 goes till n wi into xi minus theta. If, for example, we say, for instance, b is equal to minus theta, so you can see that, or you can say theta is equal to minus b. So this is assumed that this is the case here. So then we can simply replace minus theta with b here. So you can see that using this we can replace theta with minus b. Why this is done? This is done to go for a standard notation, or for the you can say neural net functions in the PyTorch and TensorFlow that use the computation and summation, so it can be done in an appropriate way. So here we can talk about what is b then. So because you may see some notations like this, that I is equal to 0 goes till n, and then xi wi. Okay, so it starts from 0 instead of 1, and then this b is already integrated with that 0. So how this is going to happen? Because when we talk about b, we are talking about b is equal to that any fixed input into weight of that bias. So this is actually bias version of this equation. Okay, pre-activation value. So when we talk about it, we can call it like this fixed input is referred as x naught, and then this weight bias is referred as w naught. So it is like this, and then when this, we can place this x naught here with w naught, we can simply replace this 0, and then this we can merge here. So this is the overall representation of a neuron. I hope it clarifies that these two equations, how that theta pre-activation value is similar to this one.